Welcome to a session on algorithms for VLSI design automation. This algorithm doesn't come under VLSI design automation only, it also can be used in many other things. But here we are going to see what this algorithm can help in the VLSI design process, or how this can help in the VLSI design process. This algorithm is mainly used in the partitioning process. I have a circuit, or I have a VLSI circuit which has millions of transistors. Okay, and it is needed to minimize the delay, right? So I want to group these big circuit into different smaller partitions so that I can minimize the delay due to the interconnection between the partitions. So I should choose the nodes such that every node in a particular group are closely connected, or if in case there are many connections between a group of nodes, I can put them in the same partition, right? Similarly, I can form such several partitions, and the interconnections between the partitions will become minimized. This interconnection between the partition is also called the cut size. So we will see how this Kernigan Lin algorithm can be used for getting a bigger partition, right? For this I have taken a graph, right, which has 6 nodes, right? A, B, C, D, E and F. The weight between the node A and B is given by 2. This weight may be due to various factors such as the length of the wire, the delay of the wire, etc. All the cost weights are given between 2 nodes. Okay, so initially I will divide this graph into 2 partitions, right? So if you look at this figure, A, B and C are closely kept, and D, E and F are close. So I'll have the initial partition as A, B, C, and the second partition as D, E, F. I've redrawn the same circuit here. Okay, the same circuit has been redrawn with A, B and C on one side and D, E and F on the other side, right? There is no change except for this in this diagram. Now I'll construct the adjacency matrix of this particular graph. For drawing the adjacency matrix, I should write all the nodes in the column as well as the row. So there are 6 nodes, A, B, C, D, E and F. Similarly, column wise also A, B, C, D, E and F. Okay, now A and A, obviously they will not have any cost between them, so I'll put them as 0. Between A and B, what do I have? I have an edge, right? I have an edge which has a weight of 2. Okay, so between A and B, I have an edge which has a cost of 2. Between A and C, what do I have? I have a edge which has a cost of 3. Okay, so between A and C, I have an edge which has a cost of 3. Between A and D, I don't have any edge, right? So I can put this as 0, right? Similarly, between A and E also, there is no connection, right? So I can put this as 0, right? And between A and F also, there is no direct connection. So I'll put this as 0. Doing this in this way, I will get a adjacency matrix of this, right? All the nodes have been shown here, and all the connections between every node is shown in this adjacency matrix. Okay, now we'll go to step 2. In step 2, we have to calculate the D factor, right? Calculation of D values. For calculating the D value, I need to find out Ix. Ix is the internal costs of x, for example, x may be found in a partition and x may be connected to y and z which are in the same partition, the sum of them is given by ix. Similarly, ex is the external costs of x. Okay, so x, y, z may be found in the same partition. I'll just draw and show you so that it will become easy for you, right? I have yeah, I have two partitions here. Okay, I'll copy the same thing, or else I'll take something else. Okay, yeah, so I have two partitions here. Okay, so in my first partition, assume I have x, y, and z, and in the next partition I have s, t, and u. Okay, this is for your understanding, this is not given in your graph, right? So what is ix? X may be connected to y and x may be connected to z, and this may have a weight of 1, this may have a weight of 2. So what will be ix? Ix will be nothing but 3. Similarly, x may be connected to s, yeah, x may be connected to s and x may be connected to u, and this may have a cost of 2 and this may have a cost of 1. Therefore ex is also 3, right? So this is ix and ex. Now dx is nothing but ex minus ix. This is the d factor, right? Using this method, we will calculate IA. IA, what is IA here? A is connected to, A is linked with B and C in the same partition. So the internal costs of A using the same approach is calculated as 5, EA is 0, IB is 2, EB is 9, and so on, right? Similarly, IC is 3, EC is 1, ID is 2, ED is 4, and so on, right? So based on these things, we have calculated DA is equal to EA minus IA, right? And this is the complete set of values. DA is 5, DB is 7, DC is minus 2, and so on. Okay, so we have calculated the D values. Okay, now step 3 is the calculation of gain. Okay, step 3 is the calculation of gain. Gain between two values x and y is given by dx plus dy minus 2cxy. Is that clear? Minus 2cxy. So using this method, I'll calculate GAD. What is this GAD? GAD is, yeah, DA plus DD minus 2CAD, right? DA plus DD minus DA, DD, everything I have calculated here. DA is minus 5, DD is 2. Okay, so what is this? This is minus 5 plus 2 minus 2 into CAD. What is CAD? CAD is the connectivity between A and D. For this, you have to refer the adjacency list. Okay, A and D, right? Connectivity between A and D is this. It is 0. So what can I write here? Yeah, so this is minus 2 into 0. Is that clear? So what will I get here? DA is minus 5, DD is, by the way, yeah, DD is 2, and this is 1. So this one GAD becomes minus 3. Am I right? DA is minus 5, DD is 2. So minus 5 plus 3. Yeah. Now in the same way, if you write all the values, you will get GAE is equal to what formula do I use? DA plus DE minus 2CAE. So what is DA? DA is minus 5 minus 3 minus 2 into 0, which is equal to minus 8. Similarly, I can calculate the values of GAF as minus 8. Okay, GBD is 1, GBE is 2, GBF is how much? 0, GCD is 0, GCE is 1, and GCF is minus 5. Okay, now how do I think this is clear. I am forming a pair between A and D, A and E, A and F. I cannot form a pair between A and B because both of them are in the same partition. Similarly, I am forming a partition between B and D, B and D, B and F, and not between B and A. Okay, so after doing this step, right, after doing this step, what do I get? Which pair has the maximum gain? The maximum gain is given by this one. Am I right? This is the pair which gives the maximum gain. I will take that as G1 crown. Okay, G1 crown is equal to 2. Okay, so now my partition 1 will be what? So G1 crown is equal to 2, and this G1 crown is responsible for what? B and D. Am I right? G1 crown is equal to GBE is equal to 2. Am I right? So what can I do now? I can swap B and E. Am I right? I think it's clear. I can swap B and E. Okay, so after swapping, how will my partition be? A is not swapped, but B is swapped. In the place of B, I have an E. C is not swapped. In partition 2, what do I have? Previously I had D, E and F. D is still there. In the place of E, I have a C and F. Am I right? A is C, D, E and F. So now can I draw the diagram for your understanding? Okay, we will draw the diagram. I'll take the circles as before. A, E and, why is it not staying? A, E and C, and then what? D, A, E and C. Sorry, I made a mistake here. Sorry. This one should be what? It should be B. Am I right? This should be B. D, B and F. Yeah. So this will be D and this will be B. Okay. And this will be F. Okay. This will be D, B and F. Yeah. So my graph will now be between A, E and C and D, B and F. Right. So how can I draw the lines now? I'll take my ruler. Right. I'll mark this as A. I'll mark this as A. This will be my E. This will be my E. This will be my C. And this will be my B, D and F. Am I right? So now there'll be a connection between A and B. There'll be a connection between uh, A and C, right? There'll be a connection between E and B. There'll be a connection between E and F. There'll be a connection between D and B. There'll be a connection between D and F. And C and E are connected, right? Okay, so I'll put the weights now. This is 2, this is 2, this is 3, this is 5, this is 1, this is 1 again, this is 2, and this is 4. So this is my new partition, am I right? Which consists of A, E, C, B, D and F. I think I'm clear now, right? So can we compare the previous ones? If you can compare the previous ones, you can find out that in the previous case we had 3 wires which ran from one partition to the other. Am I right? That I have not shown here. Yeah, 3 wires. The total edge cut cost in the previous one was 4 plus 5 plus 1, which was 10. Here it is 2 plus 5 plus 1, which is 8. So it has reduced. The cut cost has reduced, but we should not stop with this. We should go along. We should go on. Okay. Now I have swapped this. Now I have to update everything again. So it's a lengthy process, but still if you remember the formulae and the values, there's no problem at all. Now I have to update the d values, right? Update the d values. For that we use a formula called dx dash is equal to dx plus 2cxp minus 2cxq. What are these p and what is this x? So x and y are to be swapped. So as before, I am assuming that x belongs to A and y belongs to B. Okay, so I have two values p and q. Initially p was with x and q was away from x, right? Now we have interchanged the positions. So we should first put the initial partner. Which was the initial partner? The initial partner was xp, and now the new partners are xq, right? You remember in that way. So what will be the value of dA dash now? dA dash will be dA plus 2CAB. Am I right? I have swapped B. I've taken B to the next partition, but initially B was with A. Am I right? So I should put CAB. Now what has come in the place of B? E has come in the place of B. So it will be 2CAE, 2CE. Okay. So dA plus 2CAB minus 2CE. So when you substitute the values, dA we have found out, CAB you can take from the for your convenience I have taken the adjacency matrix again. What is CAB? A and B, that is 2. Am I right? Yeah. A and B, CAB is 2 and C2CAE is 0, right? So this one should be, yeah, this is 2C, sorry, it'll be 2CAE. Okay, 2CAE is 0. So substitute all those values, you will get minus 5. 2 is CAB, right? And 0 is 2CAE. Okay, so that will be minus 1. Now I have a question for you. I am going to form the updated d values, dA dash, etc. Right? I have a question now. Should B and B be taken here? Not necessary. Right? You have swapped B and E, so you can assume that B and E are temporarily locked. Can I show that as a diagram so that you will remember that? Right? I'll take this partition now. Right? I'll copy this. Sorry. Yeah, I'll copy this again. Yeah, and I'll put the same thing again. Okay, so my first partition, what does my first partition contain now? A, B is taken to the next partition, right? A, E and C, right? B and I'll write B and E here, right? E has come here, B has gone there. What are the remaining items? A is still here, C is still here, similarly here, D is still here, F is still here. So what can I do? I'm assuming E and B are temporarily locked, right? So in the upcoming steps in the first iteration, we are not going to consider E and B now, right? So for calculating the updated values also, what should I do? Should I take B and E here? No, I need not take B and D. So what are the values that I should calculate? I should calculate dA dash, dC dash, dd dash and df dash. All those values I have shown here. So from this we have to calculate the gain. The gain value is given by gxy is equal to dx dash plus dy dash minus 2cxy. What are the pairs which I can consider now? AD, I'll show it here. AD, AF, CD and CF, right? So those pairs I should consider. I've calculated the gain of GAD, I've calculated GAF, I've calculated GCD, and I've calculated GCF. Now what do I do again? I should find out which is the pair which gives me the maximum gain. So which is the pair which gives me the maximum gain here? Obviously it is GAF. Am I right? So what can I write now? I can write G2 crown is equal to GAF is equal to minus 2, because this is the maximum value. Am I right? This is the maximum gain. Okay. And so I'll write it again. A and F can be swapped. Therefore, G2 crown is equal to minus 2. Okay. So what have I done? I have swapped already. B and E are swapped. Now I'm swapping A and F, right? Okay. So can I draw the same diagram again here? This fellow. Okay. I'll take the rectangle. Right. I'll delete this. Right. I'll delete this. Okay. And what do I keep here? Already B and E have been swapped. So B and E are swapped. Sorry. Yeah. E has come here. B has gone there. And what's the next one? A and F are also swapped, right? So F will be here, A will be here. These two are locked. Am I right? So which is the one which is not swapped? Here what do I have without swapping? C is found here, and here what do I have? D is found here, right? So these are the only ones which are not locked. Same thing, I should calculate DC double dash now. DC double dash, what is the formula? The same formula. Dx dash is equal to dx double dash is equal to dx dash plus 2cxp minus 2cxq. I should calculate dc double dash. Dc double dash is equal to dc dash, which is already calculated, 2cca. Why? Now I have swapped A and F. So my C was initially with A. I'll take this first. Now my C is with F, right? New partner and initial partner, right? You remember it that way, right? So what are the values here? D double dash is equal to DC dash. You can refer minus 4 plus 2 into 3 minus 2 into 0, which is equal to 2. Similarly, DD double dash, D was initially with what? With F, initial partner, new partner. So this gives you the value of minus 2. When I calculate the gain, GCD is equal to DC double dash plus DD double dash minus 2CD, which will give me a value of 0, right? So this is my G3 dash, right? This is my G3 dash. Now I'll take the three values again. G1 dash was a result of the first step. G2 dash is the result of the second step, and G3 dash is the result of the third step. All those things we have already seen. We should take the largest partial sum. So sigma I to k gi crown. So what is that? G1 crown, G1 crown plus G2 crown, G1 crown plus G2 crown plus G3 crown, which is equal to G1 crown is 2, G1 crown plus G2 crown is minus 2 plus 2, which is 0. G1 crown plus G2 crown plus GT3 is 0. So which is the largest gain here? The largest gain is 2. Okay, that was due to a swapping of B and D. So what can I do now? I have swapped B and E here, right? So this is the next partition. This is the partition for the next iteration, right? So for the next iteration, you can take this as the initial partition, right? So you can take this as the initial partition. A, B and E are swapped, right? Lock them and go ahead and do the entire process again. So what is the stopping criteria? When do I stop, right? For the iteration 2, so you have to proceed with your iteration 2, right? And the process will stop if all three gains are negative. If all three gains are negative, or if the gain which you get from that step is lesser than this step. So if that gain is greater, you can take as that as the good partition, and if this one is better, you can take this as the best partition. So it is a lengthy process but not a difficult process, but kindly don't miss the steps. If you miss even a single step, you're sure to land into trouble. So I think it'll be clear for everyone. We'll meet with the next algorithm in the next class. Till then, it's a goodbye.